So yeah, this is last year's, or this is the 2021 AT1 R component. So yeah, essentially, it gets a bit doing using Jamovi, but then the R asks you to then replicate the Jamovi. So I've got the instructions here. Um, Essentially, it involves running an exploratory factor analysis of the um, 24 hexaco facets of personality and extracting 6 factors, looking at a scree plot, and then I guess scoring these facets. So there's 4 facets per um, hexaco domain. So the idea is you add up the hexaco facets that belong to a domain, and you can then do some correlations with the criteria, which in this case is trait emotional intelligence. So the R analysis involves doing that and then running some analyses looking at gender differences on personality, i.e. on the hexaco. Um, so yeah, let's look into how you could do that. So essentially, I would say there's 2 ways you can implement this R uh, component. You can either use ProjectTemplate, which is my kind of preferred way of doing things, but it makes things easier, but it's also a little bit more advanced. Or you could do it just with a simple R script, which is maybe a little bit more transparent and simpler if you're just learning R, but doesn't come with some of the benefits. So maybe I'll show you um, both both ways. So let's maybe start with the simple R script way. So I'll open up RStudio. And maybe I'll start a new project. And we'll put it in a directory. So I'll call it simple R 2021 assignment. So I'll say I'll put it in that directory. Okay. By creating an RStudio project, it means that if I ever want to reopen this project, everything will have the right working directories and so on. Now I want an R script in here. So I'll just call this, I don't know, whatever, simple.r. So .r just means it's just an R script. I can put whatever I want in it. Simple R commands. How's that? That's probably maybe easier for you to read. So yeah, and I can obviously type things up here and send it down to the console with Command R or Control R or whatever. Okay. The other thing we're going to need is our data. And for that, we have a CSV file with the data. Here it is. Lots of data. We have data on ID, gender, the 5 trait emotional intelligence scales, and the 24 facets of personality. So that's good. Then we have the scoring process for the hexaco. So what we're going to do now is we'll put these data files into this project. You could just put it straight in. I might put it in a little subdirectory called data. That'll just make it easier to remember. So essentially, the rules for a simple R script is specify any options, add any libraries, load any support functions, load the data, clean the data, and then run analyses. I should say clean and manipulate, prepare the data. You won't always need to do all these things. So the simplest thing is, yeah, we'll load the data. So we'll go read.csv, because it's a CSV file, data, and I can tab complete this. So that's the main thing we want to import. So we need to give the data file a name. I'll just call it R cases, because that's just what I like to call things. Raw cases, I often distinguish between the raw data file and the clean data file. About 5 letters is usually pretty good sort of length for a data frame. So you can view this thing like that. You can get a more of a spreadsheet view. You can click over here. This shows what's the objects in your R environment, and you can also view it. So there it is. Ahead, this is the other way of doing it, sort of viewing the first rows, 1,000 cases, 31 variables, and rows, etc. Names, and so on. So that's the simplest way. Now, if we go back to the instructions, it says that you have to score the 6 domains. There are more advanced ways of scoring tests, but the very most basic way, which I'll show you here, is to add up, just use simple addition. So R cases fairness plus R cases greed avoidance plus R cases modesty plus R cases what have I missed here? Sincerity, fairness, greed avoidance. I missed sincerity. There we go. So you can do that, and that will give you the sum. And if you divide by 4, that will give you the mean. So you could do something like this: honesty, humility. And now you have a score for everyone. So if you want to check that worked, if you like the data view, you can see you've got a new variable here. That's honesty, humility. So that's this, like perhaps the most intuitive way. You're simply adding up the variables, dividing by 4, and assigning it to a variable. So this is the data frame, and then a dollar, and then the new variable name. And this is the assignment operator. Slightly more sophisticated way would be, I could do it like this. So I often use this dput names R cases because it basically spurts out a list of the variables in the data frame, but quoted and sort of ready to be plonked into things. So I could take the 4 emotionality facets, like that. So that's given me the data set with just those things. And I could use the apply function. So essentially this loops over every row. If we say 1, that's 1 is rows, 2 is columns, and we could get the mean. So what this does is for each row of that data structure, it's just got the 4 variables, give me the mean. So that's the mean for each person. So that's perhaps a little bit easier to quickly loop through. So we could get the extra version ones, put it in there. Oops. And so where are we? We've got forgiveness. Like that. Did I do that right? Nope. Sometimes you get these little, you see little red lines telling you I've done something wrong.
Oh, yeah, and then I'm missing quotation mark there. That's just typical R stuff. Like, so did that work? It did. Yeah, just paste it down. And then what have we got here? We've got these four for openness. And these four for conscientiousness. Oops, I think I've done it the wrong way around. Okay, so let's see if that all runs. So something's wrong there, extra comma. So that's just, you run it, you get an error, you debug. That's normal. So okay, now we've got our test scored. We can then run the EFA of the 6 Hexaco factors. So how do you run a factor analysis? If you didn't know, you could do something like this, quick R factor anal, and this would show you some example code of how to fit a factor analysis. And I'm sure if you go something like factor analysis in R, there'll be lots of examples with templates and so on. And obviously I have my own typical way of doing things. I think there's even a blog post floating around about it. But in essence, I use the scree plot. I think it's in the psych package. So I'll make sure that that's loaded. Um, Now we need to get a data frame with just the hexaco facets. So how do you do that? So obviously you can go hey cases and start typing in all the facets, fearfulness, anxiety, but that would take a long time to write all 24 out. So another way of doing it is dput names, cases, and you can you could highlight them like that if they're in a nice order. And that would, oops, then you just need to put that C thing, which creates the vector of variable names. So that would select that data set that you could then run a scree plot on, like that. And my preferred way of doing this is to actually create variable sets. So I create a list called V, and then I call it like hexaco facets. And so instead of having to type that list of variable names, I can now access that through there. Anyway, that's the trick. It's, it just makes life easier, then you don't have to retype it every single time. And by using a list, I can just type V dollar and all my lists of little special lists of variables come up. So it's a little trick. So that brings up the scree plot. If you want to run a factor analysis, it's factor anal, and we get that little data structure. The second argument is number of factors. So you got the data, the number of factors, and yeah, you can have a rotation as well. So 6 factors and rotation equals, I'll go Promax. And there we have it. By default, R does things a little bit differently when it prints them out. It sort of has a pretty low cutoff. So if you're looking for a little few tricks,
save that to an object, and you can print, fit, and it's somewhat obscure getting these arguments, but has a cutoff and a sort argument. Personally, I don't really like the sorting rules that it has, but yeah, so you can use a more normal cutoff like 0.3. You go, yeah, oh yeah, pretty clean factor structure, sociability is cross-loading on factor 6, and so on. Anyway, interpretation is not really the aim of this video. So yeah, then the next thing was to uh, correlate the personality with these things. So you can use something like core, cases, um, and then you have to get the trait EI thing. So once again, I use this dput thing to pull out my variable names because I don't want to have to manually type them. And there they are. So you could do something like that. So it's correlating the hexaco facets with the trait emotionality intelligence scales, but I can't help myself. I'll create another variable set. So that way I can just type in the trait EI. So that's the facets, and I guess we want the domains as well. So maybe we add those ones in. If we want to get correlations with the domains, we'll just do that dput names are cases and get the hexacode domain names. Just reorder openness because that's will drive me crazy. And what about I've forgotten the little C thing. Okay. We could even create a combined thing, which is hexaco all. So I got all the hexaco domains, honesty, humility, emotionality, and so on, and then all the facets. Just a way of entering the variable names. So now we have correlations between all the hexaco and all the trait EI. One thing I do often, once I've actually got some output, is I go round to 2 decimal places. So that's kind of a bit easier to read. So that's nice. If I was actually kind of putting this into a journal article or something like that, I might go format or call it something, and then write.csv. Probably create a little output folder over here and write that file to a CSV. And then I could bring it in to Excel, format it, and then put it into my manuscript. Okay, what about gender differences? I think that was the final step of this task. So let's just check what we've got with gender. So we've got gender. Let's just check that it's all normal. It's a table, so it's female and male. So there's different ways of looking at group differences. A simple way is to, I'm trying to remember. You can do something like this. Oops. So that's running a linear regression, which is essentially what a between groups t-test is. You could do something like that, which tells you that males are 0.28 points lower on emotionality. So
The female mean is 3.19 and the male mean is 0.28 less, and that's highly statistically significant. We could also do a t-test. I might even have to look this up. How do you do a t-test? Maybe you can still do it the same way. I'm not sure. Let's see. I think you can. Yep. So that gives you more familiar t-test style output. So it shows the mean of the females and the mean of the males and typical t-test style output. So you certainly, it's a simple way to do this. You certainly could just um, loop through everything like this. That's fine. That's basic. Um, um, yeah. If you're curious about more advanced ways you could do it, you could get a nice table. So something like you could go hexaco all. So that's all the means. So you could say R cases gender equals male. Did I not do that right? What was it? It should work. Okay, there we go. So you could create a composite data frame. So you could go mean male, and you could start. You could do then SD male, SD female. So this is all just more advanced stuff. I could call it gen tab or something like this, just a random name to call it. So there's a basic difference, and then I guess you could get a D value or something like that. That's mean. I don't know which way you want to do it. Mean male, female minus mean male. There's all sorts of things you could do with the standard deviation here, but let's just do it really simple. And then you could round this table up to 2 decimal places. Oops. Did that not work? What have I done wrong? So, yeah. So I'm just going to fix that up, obviously. So now we can get a quick sense of the Cohen's d values. So at least in this sample, women were somewhat more honest, higher on honesty, humility, much higher on emotionality. Small differences here on a slightly less agreeable, slightly less conscientiousness in this sample. And then you can see the facet profile as well. And yeah, once again, you could even go crazy and add the p-values and all that sort of thing, but that's probably enough for now. All right, so just to show you, we could shut that down, and if we were to restart that, with any luck, this should just be a completely functioning script where I could run the whole script. So highlight it all and run, and it should all just run. So it's loaded the data, scored it, run these various analyses. Okay, so I wanted to show you
how you would do the exercise shown here from a previous assignment using the project template workflow. So this is loading the data, scoring it, and preparing it, and then running some basic analyses. But how do you do it if you're doing project template? So let's go through that. So I have a direct link um, oops, to this location, so I can start projects very quickly. But yeah, what I would do is I would essentially download this project template. And I think I give you a link to this in many different exercises and places. So we can download this as a zip file. Now, if you're on Windows, make sure you extract it. Copy this folder to a suitable location. So I'll call this um, I know ProjectTemp R21 one assignment, and I'll also rename the RStudio project just because that's good practice. If you're on Windows, you may be hiding the rproj thing, but yeah, that's the project template file. So before you open it, you want to bring in your data file. So that's ecases at1. So you copy that into the data file, the project template. And if you wanted to have a slightly different name, like our cases, then you can just rename it here. It will take the file name in R will match whatever it's called here, minus the .csv bit. Okay, so now we can go into project template. Sorry, we can load the project in R, and yeah, we can open this thing, and we have an initial thing that would load the project. So if we run these two commands, um, we will see that we've got our cases imported automatically. So that's good. The next thing we want to do is, so let's go back to the actual code I was writing previously. So let's look at all this. What's going on here? We're loading the psych package because we want to use that at some point for the scree plot, I believe. Now, let me just, did I shut that? So that should already be in the configuration file. It's just I use it so often. Yeah, so it's already there. So anything listed in this library is automatically imported, and some options are already specified. Our case is automatically loaded. What we need to do is put any data preparation scripts into the munge folder. So you have an R script here. When you're debugging this script, you have this little command here, which essentially loads the project, but leaves munging. It doesn't run the munge script, so it doesn't run the data manipulation step. So it's kind of getting you to the point where you're ready to create things. A note about these little errors, project template updates from time to time, so if you want to make them go away, you can just run migrate.project. The changes don't usually make any difference, but it's kind of a nag. So yeah, we can run all this, and that scores our variables and so on. The idea is that when you come back to a project, you just run these commands, the data loads, and all your little additional functions are created. So we have those scale scores and so on. Um, so yep, there we go. And then if we want to run analyses, we can put those in here. Um, so now we've got the analyses here. And so they will all run. You can put it all in one block if you like. Just a habit I have is I generally split mine into various scripts. I'm pressing shortcut keys to insert chunks. There must be a edit, uh, was it code, insert chunk? Yeah, so I just sort of, you know, divide it into little analyses. That's just sort of how I like to organize it. So we can put the correlations, gender differences. This is all optional. And in theory, you could just go, if you, not that you really need to, most of the time I don't, but yeah, you can knit it. So you got your factor analysis, your correlations, and your gender differences. Boom, boom, boom. So yeah, in review, project template's just another way of organizing things. As projects get more complicated, it's a good system. Note how I didn't have to run any library statements because it was built into the configuration file. There's a few other little options around, say, strings as factors, which is false, which is usually good. I didn't have to create a data folder because there was already one, so I could just put it in there. Yeah, a bunch of things like that. So yeah, it's just a clean way of separating the data preparation code from the analyses, which depends on everything being loaded and ready. So yeah, I hope that's helpful.